Okay, so you can use a table to find constant rate of change, and this is how we're going to do our examples today. Our first example shows the amount of money a booster club makes washing cars for a fundraiser, using the information to find the constant rate of change in dollars per car. So what you're going to do is you're going to look at the example in each of these, and if they say dollars per car, you're going to look at the table and you're going to make sure that it's dollars per car is what you're going to do the division like. So if it's dollars, you're going to put dollars on top, and car you're going to put on the bottom, and per means division. So you're going to make sure that you're going to set it up that way, even if it's in reverse in the table. So make sure that if it's in reverse in the table, that it's set up the way that it's worded in the example in the notes or in your homework or on a test. You have to make sense of it in your mind. Don't make sense of it the way that it looks, because sometimes your eyes can deceive you. Okay, so we're going to then, because it's worded that way, we're going to put the money first on top. If it's 40, then we're going to divide by 5. 40 divided by 5 would be 8. And so we'll circle that underneath to show the answer. Then 80 divided by 10 is 8. 120 divided by 15 is 8. And you can use a calculator to help you with these. These are pretty simple, but as they get more difficult, you will feel the need to use a calculator. And 160 divided by 20, you can do in your head, which is also 8. As you can observe here, this is a constant rate of change. It's a constant rate because constantly you're going to see this same rate occur. And so they're going to ask for an explanation of this. And what you're going to want to say is going to refer to the explanation. You're going to say that it's going to be $8 per car. And you're going to want to get specific with your explanation. This one doesn't really refer to anything more specific than that. Next example. The table shows the number of miles a plane traveled while in flight. Use the information to find the approximate constant rate of change in miles per minute. So what is it that they're talking about first? Right here. And then what is it that they're mentioning second? What are they mentioning first? Then the division. And then what are they mentioning under the division? Minutes. So we're going to put what number on top? 290. And the division sign. And then what number on the bottom? Even though it's reverse in the table, we're not going to let our eyes deceive us. So what is 290 divided by 30? You want to look at that more carefully? In your calculator, what do you get? If you look at that more carefully in your calculator, what do you get? That 7 at the end is just your calculator rounding all of those numbers. If we have 9.6 repeats, isn't it 9.6 repeats? And we're going to round that to the nearest tenth. What do we get? Because doesn't that next digit, that 6, round that 6 up to a 7? Okay, what is 580 divide by 60? $870 divide by 90? And 1,160 divide by 120. So what would our explanation be here? We need to be more specific there. A baby crawls 9.7 miles per minute. A plane travels 9.7 miles per minute. Do we need to get that specific? Why? Because you wouldn't know, I heard someone say, because you wouldn't know what it was that they were talking about. Are they talking about a baby crawling? Are they talking about a car driving? Are they talking about a person running? Is it reasonable to say that this could be a person jogging? Can a person jog 9 or 10 miles per minute? Absolutely not. Not at a consistent, constant rate. No way. So if we don't put that this is a plane traveling, somebody can say that is not a reasonable answer. Why would they put that down? There's no way a person could run at that rate. So we have to be specific so they know, oh, well, if it's a plane, then I can see that happening. So we have to be specific in this answer, this explanation, in order for someone to say, oh, okay, that's reasonable. Next one. The table shows the number of miles Claire drove on a trip. Use the information to find the constant rate of change in miles per hour. What's the first thing we're going to write? What am I going to write? 130? Divide by 2. And what is 130 divided by 2? 65. Let's write that down. What next? 260 divided by 4. And what do we get? 65. Then what? Which equals 65 as well. And next? 520 divided by 8. And what do we get? 65. So what's our explanation here? What does this tell us, this information? Try again. So what does this information tell us? What are we going to write as our explanation? Claire drove 65 miles per hour. Does that tell us what we need to know? This time it's miles per hour instead of miles per minute. Is it reasonable to think that she could drive 65 miles per hour? Do people drive 65 miles per hour? Yes. When the speed limit's 65, they drive 65 miles per hour. That's usually what the speed limit is on a 4-lane highway anymore. I think that's a reasonable explanation.